you're up to as this function. It'd be a little easy to do to come up with that answer. So what is our numerator? Anyone have that? Mesh, I saw you working on it.
No, I just said S of 3.
Okay, what do you have for S of 3?
455.9.
455.9. Anyone want to match that? Have that? Okay. S of 0, I think that's 500 though, isn't it? That's easy enough to do. Divided by 3. Now is 455.9 an exact answer? Exact? Okay, good. So we come up with then, let me check it against mine. I have negative 14.7. Is that an approximate? Okay. Give me some units here. Meters per second. Okay. So now between and within the first 3 seconds, again, I don't think we've done enough of this in this class. What does this really mean? I'll spell that out. The object has fallen an average of 14.7 meters for every second. Does it say that every second it did fall 14.7 meters? No, it didn't say it did for every second. It says on an average. If you took all the, between 0 and 1 second and 1 and 2 seconds and 2 and 3 seconds, if you took those, how much it fell between each of those, and you averaged them up, the amount that it fell, the average of how much it fell would be 14.7 seconds. Okay, for all of those. Now, use the mean value theorem to verify that at some time during the first 3 seconds of fall, the instantaneous rate of change equals the average velocity, and find the time when that actually did take place. Okay, so we know that it's continuous. We know that it's differentiable. We could have actually put those down here in part B, but we're going to leave them where they are. What do we now need to do? Take the derivative, yes. So we're going to take the derivative of s of t, which happens to be the velocity function. Okay, the derivative of position is velocity, and I think we can all come up with negative 9.8t as the derivative of that. So what? So what? Now what do I do? What's the next step? Yes, Emma. Okay. And we're trying to find at what point in time this actually took place. So t has a value of, or approximately 1.5. 1.5 what? Seconds. So at halfway through this, at 1.5 seconds, the object at that second, that's the second at which what happens? At 1.5 seconds, the object was falling at a rate of 14.7 meters per second. Now, take your inspires. We're going to graph this. We're going to see for sure what this looks like. So, get another graph page. And I'm going to put in, now which function do I put in? I found that some students have a question about this. Do I put in the derivative function, or do I put in the original function? The original. I'm trying to find the tangent on the original circle that has what slope? Negative 14.7. Okay, so let's see. So this would be x squared plus 500. And we got to change our window, don't we? It sure is. We'll go back and make sure I type this in correctly. I got a little distracted there. Okay, so I'm going to graph that. Of course, I see nothing. So we know that that's because we got to get a lot more on our height on this. And I only want to go between 0 and 3 on seconds. So I really don't need to see the entire parabola here. Now we can leave it at this and work with it, but I think for our benefit, I'm going to change this to be -1 to 5 and scale it by 1. And then, you know, the position of this, if the position gets to be negative, what does that mean? The object's falling from 500 feet. At some point in time, the position has a negative value. What does that mean? What? It hit the ground? It's going through the ground, yeah. It's made a crater. It's below ground level, okay? So we don't really need to have a lot of negative here because I'm just going to put this so we can see the origin here. And we know we need at least 500 feet. I mean, that's where it's starting from. And so I'm going to make it about 600, something like that. Okay. What I didn't do was scale it, but we'll leave it like this. So this is my function. Something happened to my, yeah, okay. I'm going to change this because I don't see my origin after all. I'm going to make this -50 so I can see the origin. And while I'm here, I'll just scale this by 100. Okay, now I see the origin. I know exactly where this is. So somewhere between 0 and 3 seconds, this thing is has a slope of how much? Now, how are we going to show that on here? I can think of a couple ways that you could show this to me. Come up with one. Draw a tangent line where? Okay, at point 1.5, and then do what? Find the slope and hope that the slope is what? Yeah, close to -14.7. Okay, so I can see doing that. Since you're all familiar with that, I'm going to do something a little different. I'm going to place points, and I'm going to place a point, 2 points on here. And my points are going to be at my input of my, started at the end of my interval, so at 0. And then at, now you don't have to do this, you know, you can continue as Lindsay told us to do. It's a very good way of doing it, but I just want to show you something different. I'm going to put a line through these points, okay, and I'm going to measure the slope of that, and sure enough, the slope is what we said it was going to be. So let me label that so I don't lose track of what it is later on. Okay. Now, yeah, I'm going to go down here to construct. And if I construct a parallel, I want to construct a parallel of that line to a point on the curve. So I'm just going to do a parallel. Did you see how I did that? Menu, went down to construction, went to parallel, and then I let it go down to where it said line. I'm choosing the line first instead of the point. So I choose the line, and then I go up to where it says, you know, point on. It said point on there, and I then press enter, and then it placed it where you see it. Okay, so I'm going to construct, because what we're saying is that the tangent line has the same slope as the secant line, which means the tangent line and the secant line are parallel lines. And so I'm just going to choose parallel there. Okay, now, Brandon, what do I need to do, though, to finish this up? A couple of things I can think of we need to do. Okay, is it between 0 and 3?
Yeah,
okay, I already did that. Okay, but we got this down. Now from here, what do I need to do to finish it up? Okay, so I would like to be able to find the coordinates of this point right there. Okay, once I have the coordinates and it's 1.5, that helps me, but I also want to verify something else. We know this should be true. If we constructed parallel lines, it should be true, but I'd like to kind of measure the slope of that line, make sure that the slope says that. So, yeah, whoops, that's not what I wanted. We'll go back down to current. Menu and actions, and I want to do coordinates and equations, and if I look at the coordinate of that point, is that the same thing that I got, Brandon? I've forgotten what I had over here. 1.5? That's not 1.5. Is this 1.5 an absolute exact answer? Or is that rounded to the nearest tenth? Check your Inspire. I didn't put that in my Inspire, but you guys did. Is 1.5 an exact, or was that an approximate? It came out exact? Okay, so then I better check what I've got here to make sure. So I'm going to go back to the calculator and put my information in. Okay, well, was the negative 14.7 exact or approximate? It was exact also? Okay, well then I'm going to do what I should have done from the very beginning. Oh, let's see here. What's asked me to do is add a calculator. Okay, now I'm ready to go, and I'm going to define, and what number am I on? F2 of x? Do you remember? Yeah, F2 of x. So I'll actually, let me show you what else we could do instead of typing it in again. Since I've already got that, I can just do a recall definition. F2 of x, there we go. Okay, and I want a fraction, and I want F2 of 3 subtract F2 of 0. Help me out if I'm doing something that I'm not thinking as I'm typing here. Divide by 3. Now that, I don't know that I would say that that's an exact answer. The reason is because I got a 4.9. Let's see, if I take 4.9 times 9, I get how much? How much? 0.4, 44.1, okay. So if I take 44.1 and I subtract from that 500, oh, well, wait a minute, though. If I put, oh, I see. I just asked you what 3 squared times 4.9 is. Okay, sorry. I was thinking that we were on the other piece of that already. I'm getting confused here. Plus, how about that? Okay, minus, and if I put 0 in there, I get 500. Okay.